Well, we've recently talked about mathematical or algebraic expressions, right? They're the phrases of the mathematical sentences. They're the variables and numbers and operations combined in some meaningful way. We're going to now narrow that down a little bit and talk about a specific type of expression called a polynomial. So what is a polynomial? A polynomial is an expression. That's the first important thing. It's a mathematical expression. So it has a number, variable, operations. But it only has addition, subtraction, and multiplication. So what you'll notice is division is left off of that list. The other thing, it has to have exponents it can have exponents, but they have to be non-negative integers. They have to be non-negative. That's why I'm going to phrase that. Non-negative integers exponents. Another way to phrase that is whole number exponents. Exponents have to be 0, 1, 2, 3, etc. So any exponents on the variables can't be fractions, they can't be decimals, they have to be, or can't be negative. 0, 1, 2, 3. Okay, so that's what a polynomial is. We're often going to work with polynomials that look like, something like this. X to the second power minus 7x plus 3. This is going to be a common looking polynomial. Notice it meets all of those criteria that we just said. It only has addition, subtraction, and multiplication. Plus, minus, and then 7x is multiplication. Even x squared as an exponent is multiplication. There are exponents. There's a 2. If we have just a variable all by itself with no exponent, there's an implied 1 there. So that's a non-negative integer exponent. But as we're going to look into the dive deeper into polynomials here. So we're going to look at what's called a classification system of polynomials. Classifying, which means different types of polynomials. So the first thing we're going to look at is the number of terms. Number of terms. So a polynomial can look like this. It can look like this. It can look like this. It can even have more terms than that. We're just going to look at these 3 to start, though. And so if you think about the word term that we've been mentioning, terms are things that are separated by addition signs. So we have a term of 2x squared in this one. There are no addition signs. So how many terms are there? Just 1, right? 1 term. And we have a name for that. We have a name for that thing. It is called a monomial. Mono, a prefix meaning 1. In the second one, we have 2x squared plus 4x. So we have 2 terms in this one. A 2-term polynomial is called a binomial, with bi being the prefix. That means 2. And in the last polynomial, we have 2x squared, we have 4x, and then we have minus 5. Remember, we can put a plus sign with the negative there. So the last constant term is a negative 5. But there are three separate terms, and that is a you guessed it, trinomial. Yes, tri with the prefix meaning three. So these are all types of polynomials. They're just the way we classify them into different types. Another thing we can do to sort of analyze our polynomials is look at what's called the degree. So the degree, for now, we're going to explore the degree more later. But when you see degree, think exponent. Okay, so think exponent. There's a little more to it than that, but for now, that's what we need to know. So this first polynomial, let's say 2x to the third. We would say that this is a monomial because it has one term, and it is degree 3. Or we would say it's third degree. Okay, because that's the exponent. If we have a polynomial with two terms, 2x squared plus 4x. Well, now we have two separate terms, right? We've got a 2x squared, and we've got a 4x, and the x has an exponent of 1. And so we say that this thing is a binomial, but you always go with the higher of the two degrees. So this is higher than 1. 2 is higher than 1. So we say this is degree 2. And so the polynomial would have the second degree. It would be a second degree binomial. Second degree binomial. So this was a third degree monomial. Third degree monomial. And this is a second degree binomial. Let's go one more. 5x to the fourth minus 7x squared plus 2x. Okay? So we have three separate terms. 1, 2, 3. We have exponents of 4, 2, and 1. The highest of those is 4. So we would say that this thing is a fourth degree trinomial. Tri because it has three terms, fourth degree because it's the highest exponent. So that's how we talk about degrees. That's how we classify our polynomials. And then the last thing we're going to talk about for now with polynomials is order. Specifically, descending order. So, I'm going to give you a trinomial. 7 plus 2x squared plus 4x. You'd agree that's a trinomial, right? We have three terms. We have 1, 2, 3. So, now what I wanted to look at is the degree. So the degree of each term. Degree of each term. So this has a 2, so that's degree 2. This has a 1, so that's degree 1. Constants, a constant is actually a term of degree 0. Degree 0. So there's an invisible x to the 0 there. Remember, anything to the 0 power is equal to 1? Go back to the very first lesson. So we have degrees of 0, 2, and 1. The common way for us to write our polynomials, this is just sort of a mathematical convention, is we write our polynomials in order. We put the terms in order from highest degree to lowest degree. We put the terms in descending order. So we're going to write in descending order of degree of x, because all our variables that we're using here are all x's. So we look at those three terms. We say, which one has the highest degree? Well, it's the degree 2 term. It's got a plus in front of it, so it's positive. So I'm going to write positive 2x squared as my very first term. And then I look at the others. I say, well, the next one would be the 4x, because it's to the first. It's plus 4x, so I write plus 4x. I don't need to write to the first. That was just there for me to know that it's there. And then my last one is the 7. It's degree 0. It's positive 7. And because I'm going to write it after another term, I have to write plus 7. So now our polynomial is in descending order. The exponents are 2, 1, and then an invisible x to the 0. Descending order of powers or degrees of x. And that's going to be the common way that we write our polynomials.